Hi everyone! Now it's a turn for a new video. During this video I would like to discuss with you really very interesting topic. I would like to compare two persistent framework. One persistent framework is very popular and very widespread. Its name is JPA or Spring Data JPA. Another one is a Spring Data Relational or Spring Data JDBC. I have chosen these two frameworks because they look very similar, but the difference is that Spring Data Relational is based on a very interesting approach to build modern IT systems. The name of this approach is DDD, or Domain-Driven Design. I am pretty sure that most of you have heard about it, or even have read some literature or some articles about it. But from my point of view, Spring Data JDBC is the first vivid attempt to implement DDD approaches. Then, what is a Spring Data Relational or Spring Data JDBC? Spring Data JDBC, as I said, is a persistence framework that is not as complex as Spring Data JPA. Later on, I will show you a real comparing table where I collected feature from Spring Data JDBC and Spring Data JPA, and where I have shown what is the real difference between them on a program level, on a code level. How we can say what is a Spring Data JDBC in other words. Spring Data JDBC model applies core Spring concepts to the development of solutions that use JDBC database drivers aligned with domain-driven design principles. There are two very famous books about DDD. One is called Red Book, another one is called a Blue Book. I highly recommend to read this book. Moreover, you can find some information on the internet that first you need to read Blue Book and then you should read Red Book or vice versa. From my point of view, if you would read it 2 times in different order, it's the best approach to understand how domain-driven design works. Before jumping to real examples, let us say several words about domain-driven design itself and about the connection between domain-driven design and relational databases. All Spring Data models are inspired by concept of repository, aggregate, and aggregate root from domain-driven design. An aggregate is a group of entities that is guaranteed to be consistent between atomic changes to it. References across aggregates are not guaranteed to be consistent at all times. They are guaranteed to become consistent eventually. Each aggregate has exactly one aggregate root, which is one of the entities of the aggregate. The aggregate gets manipulated only through methods on the aggregate root. These are the atomic changes mentioned earlier. Let us summarize. What we should remember about aggregates each time when we deal with it. Aggregate is a set of entities. There is one entity which is an aggregate root. All changes are applied on aggregate as a whole thing. These changes are atomic. It means that for example, if we retrieve an aggregate, then all entities of aggregate are retrieved at once. If we are going to save aggregate, it means that all entities are being saved as a one atomic operation. And a repository is an abstraction of a persistent store that looks like a collection of all the aggregates of certain type. Then already now we can highlight the first differences between JPA and Spring Data JDBC. In Spring Data JPA, we operate with the topic object or entity. Hibernate under the hood maps our tables on our objects. In Spring Data JDBC, we need to think how our aggregate would look like. What will represent an aggregate root, which entity will be aggregate root, and which other entities will be part of our aggregate. To choose correct size of the aggregate is very important, but very tricky. In Spring Data JPA, we create a repository per entity. But in Spring Data JDBC, we create a repository per aggregate. Also, in Spring Data JDBC, aggregate is retrieved as one undividable thing. The set of entities which represent an aggregate are retrieved as one undividable thing. In Spring Data JPA, collections of entities might be retrieved eager or lazily, but in Spring Data JDBC, collections of entities are retrieved eager. Here I am speaking about collections which is a part of entity in case of JPA and is a part of aggregate in case of Spring Data JDBC. Now I would like to present you a data model which I will use in a program code. This data model consists of three tables. One table stores information about owner, another table stores information about car, and the third table stores information about repairing of the car. There is a relationship between table owner and the car, and it means that owner can have one or more cars. It means that there is a relationship one to many. And car can have zero or one or more repairings of itself. It means that there is a relationship between car and repairings one to many. And in this data model, let's say these three tables, these three entities will represent an aggregate. Aggregate root here will be an owner, and car entity and repairing entity will be a part of aggregate. When I will retrieve aggregate, or when I will apply retrieving operation on owner, it means that car and repairing will be retrieved together with entries of owner table. Also, we can see that car have a model ID and mark ID. It's a references. Let's say it's a reference to a model or to mark, but model and mark are not a part of our aggregate, and here we have only references. And if we would like to retrieve a model or mark, we should send another query to our database level. Okay, let us now jump to Java code and take a look how our classes look like when we're using Spring Data JDBC. First class is a class owner, and here we doesn't have any annotation, something like entity. We just have annotation table, and this is just to mark that this class belongs to table owner. When the names are equal, this annotation is not necessary. And also here we have fields which represents fields in the table. One field is marked with annotation ID. It means that this is something like a primary key. But in terms of aggregate, and in terms of DDD, there is no such definition as a primary key. There is an ID. Also, in our owner, we have name, address, city. We have telephone number, and also we have a collection of car. And here, in Spring Data JDBC, we doesn't have any annotation, something like one-to-many. Here we have a annotation mapped collection, which is the analog of one-to-many. Also here we have a class car, which represents a car. Here we also have some fields of the car, some attributes of this entity. And here we have a collection repairing set. What is interesting here? Here I have written some comments that in JPA it's one-to-many, but in Spring Data JDBC it's a mapped collection. As I already said, model and mark is not a part of our aggregate. And if you would like to retrieve model by ID, we should retrieve it in a separate request. And the third class is a class repairing. Here we have only three fields, and again we have some identifier of repairing, which is marked with annotation with ID. Another important thing here is that, for example, in JPA, we have some strategies which allows us to generate ID out of the box. In Spring Data JDBC, we doesn't have such strategies, and generation of ID is our headache. We can do it manually or we should take it from the database, but again, it's our headache. And here we have our repository, our owner repository. We have only one repository because in Spring Data JDBC, according to this ideology of DDD, we need to write repository only for aggregate root. And as I already said, our aggregate root is the owner. That's why we have owner repository. In our owner repository, we have three methods. One method find by ID, another one find by last name, and the third one it's a save. Later on, I will show you, for example, how many database queries will be generated when we call find by ID method. But for now, let us summarize what is the real difference between Spring Data JPA and Spring Data JDBC, let's say on entity level. Then I would highlight the following differences between JPA and Spring Data JDBC on entity level. In JPA, we annotate our table class with add entity. In Spring Data JDBC, we should think with an aggregate abstraction. In JPA, there is a strategies for ID generation out of the box for us. In Spring Data JDBC, we should manually care about ID generation. In JPA, there is an entity lifecycle mechanisms, something like L1 cache, dirty checks, automatic flushing, some sort of detached entity. In Spring Data JDBC, there is no entity lifecycle. There is no hidden logic for insert, update, delete. If you would like to make some manipulation with data, we should do it by ourselves. In JPA, cascade operations are supported. In Spring Data JDBC, the referential integrity between entities and between aggregates on code level is our headache. In JPA, one-to-many, many-to-one, one-to-one, many-to-many relationships are supported. And such relations can be lazy or eager. In Spring Data JDBC, one-to-many and one-to-one relationships are supported. No many-to-many relationship support. All relations are eager. If we return to program code again, we can find here some test class in which I am calling find by ID method of our owner repository. If we take a look on a log, we can find that during this invocation, 3 SQL queries are generated. One for owner, one for car, and one for repairing. As a summarization of that, I would say that 1 plus 1, n plus 1 problem is a normal situation for Spring Data JDBC. If you would like to avoid it, then we need to write a native query for each method of repository. At the end of the video, I would leave a link to my GitHub repository where you would be able to find this project and play with this code by your own. Now let us touch another interesting aspect of Spring Data JDBC and answer the question why Spring Data JDBC doesn't support many-to-many. Spring Data JDBC preserves the DDD principles and rules. In DDD, to manipulate with aggregates, it's important to think about and in implementation to support the transaction boundaries of the aggregate. Without many-to-many support, we clearly define boundaries of the aggregate, completely decouple the two aggregates involved. If you need to reflect many-to-many tables in your Java code, you need to use another Java class. And that's all. So colleagues, now we at the end. By using this link, you can find the source of the project which we have observed during our conversation. If you like this video, please put a sign like on the YouTube. I would like to say thank you, and I hope this information would help you in your professional life. Once again, thanks a lot and bye.